If you missed last Thursday's class, not only did you miss the Chapter 10 test, you also missed our little introduction into area. We discussed on that day that area is measured in square units. Here you see a picture of what is supposed to be a square that is 1 foot in both directions. And we would say that this object is a unit of area known as 1 square foot. Okay. Something that you probably already know is that you can take a rectangle, and if you know how long it is and how wide it is, depending on what you call length and width, but if you know its 2 dimensions, then you should know that its area will just be those dimensions multiplied together. We usually call them length and width, and here that would be 3 times 2 would be 6, and you could see that we do have 6 little squares, 1, 2, 3, 4, 5, 6. So the area of that rectangle is 6 square units of whatever unit that might be. What we proceeded to show then on Friday, we got out some scissors and we looked at a parallelogram that we were given. And a parallelogram, its dimensions are called its base, which could be any of its sides. Now remember, opposite sides are congruent. If that's a B, then that's B over there as well. What we said was, if we took this little guy, this little section here, and just temporarily lost it, and put it over on the other end, we would turn that into a rectangle that has a one side length of B and the other side length of H. So the area of the parallelogram should also be B times H. But what you have to be careful about on parallelograms is that the height, unlike a rectangle that has its height being one of its side lengths, the height of a rectangle is not one of its sides. It is the distance between a pair of opposite sides that we refer to as bases. Okay, with that in mind, here's this problem number 4 on page 598, and they want us to find the area of this parallelogram. They've given us that this side is 10, that one's 13. Now I could also put this as 13, and I could put that as 10. That's because I'm dealing with a parallelogram whose opposite sides have to be equal. Now, remember, the height measures the distance between a pair of opposite sides. So I could use the length of this, if I could figure it out, to get the height. Okay, well in this particular section, they make it maybe harder than it needs to be to get started, in that they make you go back and work the Pythagorean theorem or 30, 60, 90 or 45, 45, 90 rules. So what we should know is that if I use the rule of 45, 45, 90s, that hypotenuse is leg root 2, then that will be that 10 is equal to h root 2. If I divide by root 2, I'll have h is 10 over the square root of 2. I'll go ahead and simplify this. I'll multiply by root 2 over root 2. That's 10 square root 2 over 2, or 5 square root 2. I now know the base and height. So the area of this parallelogram is its base, 13, times its height, 5 square root 2, or 65 square root 2 units. And in this case, I know the units, they're yards, squared, or square yards. Okay, so you'll be working some problems like that. The other type of problem that you're working in this section is one where we get a figure that has rectangular parts, but in and of itself, it's not a rectangle. I'll draw one of those. If you need to pause this, go ahead. So this is number 16 on the same page. We have a figure that looks like this. At least a little bit like that. That's 7, that's 7. They give me this length here is 15. this whole top is, no, this length on that guy is 12, and up and down he is 3, and we know that this is 4. Okay, and these are all centimeters. And we're supposed to find the area, okay, of the shaded region. Now, let me show you what's shaded. Okay, now it's that. All right, there's a lot of different ways to approach this problem. But what you have to start with is an idea before you start throwing numbers down. And my idea is going to be this. If I close that in, then if that's 4, that's 4. This whole guy right here is 7 plus 7 is 14, plus a 4 is 18. So, if I would get the area of the big rectangle on the outside as though it was solid and subtract away the areas of the other 2 rectangles. Now, it looks like I closed my book a little too early here because there's one more dimension that I don't see up there, unfortunately. Sorry about that. Almost back to you. Okay. This little distance right here is 8, and that was sort of critical. So, my idea here is going to be to say, we won't need the parallelogram because we're dealing with all rectangles here, although a rectangle is a special parallelogram, that the area shaded is equal to the area of the rectangle on the outside minus the areas of the 2 unshaded rectangles. Okay. Well, okay, let's see what we've got. Area shaded equals. Well, the area of the rectangle on the outside is length times width is 18 times 15. Okay, minus the 2 rectangles on the inside. Well, this guy is 8 by 4, so it's 8 times 4. And this guy is 12 by 3, so it's 12 times 3. And at that point, you're just going to grab a calculator. Luckily, I've got my iPad here, so I'll use my iPad's calculator. Good old Power 1 SL. And we've got this. We have 18 times 15 minus 8 times 4 minus 12 times 3. And this is 202. So the shaded area is 202 square units. In this case, they were centimeters, so square centimeters. And that's all there is to our first section on areas. Good luck with your homework. Enjoy it. It's math.